Myself Dr. Susmitha. I am working as Assistant Professor in Chemistry in Institute of Aeronautical Engineering. Today we are going to discuss about ion exchange method, which is a very important method in softening of water. By end of this topic, the students will be able to know and will be able to do how to remove hardness causing salts from the water and convert the hard water into soft water. What is softening of water? The hard water, as you already know, the hard water, it contains the salts of calcium and magnesium with the anions of chlorides, sulfates, carbonates and bicarbonates, nitrates. So many ions will be present. So this hard water, when it is converted into soft water, means the salts that are responsible for causing hardness in water are removed, and thus converting the hard water into soft water is called softening of water. So softening of water, it is nothing but the process of conversion of hard water into soft water. So the processing of water, that is the softening of water, is converted or divided into two types. One is the internal method and the other is external method. Generally, in industries, the water, it is generally used for the production of steam. So for the production of steam, the water should be heated at high temperatures. So this process is carried out in boilers. So for the production of steam, if hard water is used, the boilers which are used for the generation of the steam generally face several problems like the formation of scales and sludges. If these scales and sludges are formed inside the boilers because of the hard water and because of the salts that are responsible for hardness, the boiler, it will lose its efficiency and 100% steam generation cannot take place. So always it is preferable, and industrialists always prefer to generate steam by using water which is soft. Means the hardness causing salts must not be present in water that is fed into the boiler for the production of steam. So this process of softening, it is generally done outside the boiler and inside the boiler. If the softening process, that is the conversion of hard water into soft water, is done outside the boiler externally, it is called external treatment of boiler feed water. Now, if the softening of water, that is the conversion of hard water into soft water, is done internally, means if the hard water is fed into the boiler and then by adding some chemicals like calgon, sodium phosphate, so many chemicals are there. By adding these chemicals inside the boiler, the troubles that are caused because of the hardness causing salts will be stopped. So such type of treatment is called internal treatment. So internal methods, they are the method where the hard water is converted into soft water by adding chemicals inside the boiler itself. Once the water is fed into the boiler and internally the water is made soft, that is called the internal method. And the external method is, first the hard water, it is converted into soft water, and then once the soft water is obtained, then it is fed into the boiler. Here the treatment, it is done outside the boiler. So it is called external treatment method. So there are three methods in this external methods. They are the ion exchange process, zeolite process and lime soda process. Today we are going to study about the ion exchange process, which is a perfect and very accurate method. So the main principle working in this ion exchange process is the reversible exchange of the ions. Ions, in essence, generally there are two types of ions, cations and anions. So there will be a reversible exchange of ions between the stationary phase and mobile phase in this ion exchange process. So this is the main working principle. Generally, this ion exchange process follows the principle of ion exchange chromatography. Generally, when the chromatography word comes to our mind, obviously the stationary phase and mobile phase, these are the two terms which will strike. The stationary phase, it is a phase or a part of the chromatography where there will be no movement, means the stationary, the word itself indicates that no movement, it will be present as such. So that comes under the stationary phase. And mobile phase, it is the solution or the part of the chromatography which will move or which will pass through the stationary phase. phase. So in this, the main principle of the ion exchange process is the reversible exchange of ions takes place. Where the reversible exchange will take place? Between the stationary phase and mobile phase. Means the stationary ion exchange phase means nothing but the stationary phase and the liquid mobile phase. Okay, this is a working principle in this ion exchange process. So in this ion exchange process, the main component or the very vital element that plays important role is the ion exchange resin. These ion exchange resins are nothing but the copolymers of very high molecular weight, which are cross-linked polymers that contain a functional group. So ion exchange resins, they are nothing but the cross-linked or interlinked copolymers of high molecular weight with a long chain, and the important part is they contain a functional group. Depending on the type of the functional group, these ion exchange resins are classified into two types. One is a cation exchange resin and the other is a anion exchange resin. So the word itself indicates cation exchange resin, means it has something to do with the cations, means it can exchange the cations that are present in the mobile phase with itself. And the anion exchange resin means it has something to do with the anions, means the anion exchange resins can replace the anions that are present in the mobile phase with the anions that are present in this resin. So let us see what is the process or mechanism that is followed in this ion exchange resins in detail. So the cation, let us first talk about the exchange resins. The cation exchange resin, it is represented as RH. Here R means it is nothing but the copolymer. Generally, these ion exchange resins are styrene divinyl benzene copolymers. In whether it is a cation or an anion, generally the long chain polymers, they are generally made up of styrene divinyl benzene copolymers with a functional group. Here, if the functional group present is COOH or HSO3, then we call it cation exchange resin. Means here COOH means this H plus ion will be present. Means the cation exchange resin, it is nothing but represented as RH. So here R, it can be the copolymer or the long chain with a functional group, and in the functional group the H plus ions must be present, so that these H plus ions can replace the cations that are present in the mobile phase. We will talk about that later, but as if now, the cation exchange resins, they are represented as RH, and they are nothing but the copolymers that are cross-linked copolymers, styrene divinyl benzene copolymers with a functional group of COOH or HSO3. It can be anything, but it should contain H plus ions. H plus ions play important role in this cation exchange resins. Next comes the anion exchange resin. These anion exchange resins are represented as R-OH, means they should contain the OH minus ions, which will be replaceable with the anions that are present in the mobile phase. Okay, this R-OH, it is nothing but the anion exchange resins. So these anion exchange resins in general, they are nothing but the styrene divinyl benzene copolymers which contain ammonia or tertiary ammonium salts. Means they should contain OH minus ions. See, if you see the structure here, this is a cation exchange resin. Here H plus ions are present, which are the exchangeable ions with the cations, and in this anion exchange resins, OH minus ions are present, which are nothing but the exchangeable. These OH minus ions are exchangeable with the anions that are present in the water or the mobile phase. Here in this ion exchange chromatography, we are talking about the conversion of hard water into soft water. Means the hard water, it contains cations and anions. As in our earlier classes, I told, the hard water, it contains the salts of calcium and magnesium ions which are forming the salts with chloride, sulfate, carbonate and bicarbonates. Nothing but the calcium chloride, magnesium chloride. Here the hard water, it contains calcium and magnesium ions, which are the cations, and the anions are the chlorides, bicarbonates, sulfates, carbonates. These are the anions that are responsible for hardness. So if I remove these cations and if I remove these anions from the water, then that water, it will be converted into soft water. So in order to remove these cations and anions, I am using this ion exchange resins. So in order to remove these cations, I am using the cation exchange resin, and in order to remove these anions, I am using the anion exchange resin. So in cation exchange resin, what is happening? The H plus ions, see, in this cation exchange resin, H plus ions are present. So these H plus ions will replace the calcium ions. So in this way, this calcium is getting entrapped into this resin. It is not staying back in the water. It is getting entrapped into the exchange of ions is taking place. In this way, I am removing cations, and here the OH minus ions are replaced with the anions, whatever is present in the mobile phase or the water. So here also the exchange of anions is taking place. So in this way, this is the main working principle in this ion exchange process, where the cations and anions are removed with the help of the ion exchange resins, namely cation exchange resin and anion exchange resin. This is all about the ion exchange resin. So till here, what we have learned is the ion exchange process, that is the softening of water, external treatment of softening or external treatment of boiler feed water, or the external methods for the conversion of hard water into soft water. In that, 3 methods are there, like zeolite process, lime soda process, and ion exchange process. In ion exchange process, we are making use of the ion exchange resins, namely cation exchange resins and anion exchange resins, for the removal of positive ions, that is the cations, and the negative ions, that is the anions, from the water. If these calcium and magnesium ions and these chloride, sulfates, carbonates and bicarbonate ions are removed from the water, then obviously the water will be free from the salts of hardness from the salts that are causing hardness to water, and obviously the hard water, it will convert into soft water. Now let us see the construction of the ion exchange method, how the apparatus are arranged, and what are the important parts, and what are the inlets, and how the water is collected from the outlets. Here, if you observe carefully, there are 2 chambers. Okay, these 2 chambers, actually they must be connected like this. It is somehow missing. Okay, so this ion exchange process, it contains 2 chambers. One is a cation exchange chamber and the other is a anion exchange chamber. Now let us see the construction of the cation exchange chamber. So in this cation exchange chamber, if you observe, 2 important parts are there. One which contains the cation exchange resin, and the other, it is nothing but the gravel. Okay, the cation exchange chamber, it contains a cation exchange resin and the gravel, and there is one inlet into this chamber which is used to enter the mobile phase, nothing but the hard water. An inlet is there which is used for the an inlet, it is used for the hard water's entry into the chamber, and another inlet, this is another inlet which is used for the regeneration of the resin. Regarding this regeneration, we will discuss later, but as if now, just talking about the construction of this ion exchange process, this cation exchange chamber, it contains a cation exchange resin and a gravel and 2 inlets, one inlet for the hard water and another inlet for regeneration. Okay, this is about the construction. And here an outlet is there which is used for washings. After regeneration, some washings will be there, and those washings will be collected through this outlet, and another outlet, it is there which is connected to the another chamber of this ion exchange process, that is the anion exchange chamber. So talking about the construction of this anion exchange chamber, this anion exchange chamber also, it has 2 important parts. One is a anion exchange resin and the other one, it is nothing but the gravel. for easy percolation of the water. Gravel, it is generally used for the percolation of the water. So the ion exchange process construction, the chambers that are used for this ion exchange process, it contains two different chambers, one with the anion exchange resin and the other with the cation exchange resin. So in this anion exchange resin also two inlets are there. One inlet for the raw water or water which is collected from the cation exchange chamber, it will enter into the anion exchange chamber, and the other inlet is for the regeneration of the anion exchange resin. This is another inlet which is used for the regeneration of the anion exchange resin. Once and this is an outlet which is used to collect the washings, and another outlet it will be there for the collection of the soft water. Okay, soft water, it is collected from the another outlet. This is all about the construction of the ion exchange process apparatus. Okay. So first, from this diagram itself, you can easily make it out that first we will be removing the cations, because the cations exchange resin is used first. Once all the cations are removed from the water, then it will enter into the anion exchange chamber and all the anions are removed. Now let us see what is the process that is happening and how the cations and anions are removed with the help of this ion exchange resins. Now the first step is I should have the hard water in which the ions that are responsible for hardness causing hardness causing salts or the ions must be removed. As you know already, the calcium and magnesium, these are the main cations that I have to remove from the water, so that the water, it can hard water or the raw water, it can be converted into soft water. So first I will be passing through hard water through this inlet. Now what will happen? The hard water, it contains calcium and magnesium ions. When this hard water enters into this ion exchange resin, what will happen? This ion exchange resin, usually they contain H+ ions. So this H+ ions will be replaced with the calcium ions. This H+ ion which is present, it is replaced with the calcium ions. Whatever H+ ions that is present in this resin, it will enter into this water. Just exchange of ions is taking place. Okay, this can be better understood by taking this example. See, this is an cation exchange resin and it contains only H+ ions. See, all these orange, let us think these orange circles, these are nothing, these represent only H+ ions. Now initially, before allowing the hard water or the raw water into the cation chamber, initially this cation exchange resin, this whole cation exchange resin contains only H+ ions, means contains only orange colored circles which are nothing but H+. Only orange colored circles are present. Now what will happen? Now I am allowing the hard water to enter into the cation exchange resin. So what is happening? Let us imagine, or let us think that these purple colored circles, they are nothing but the calcium or magnesium ions. Okay, now I am allowing the hard water to enter into it. Now this H+ ion, it will be replaced with the calcium in the resin itself. Means it's a stationary phase, it doesn't move. Sorry. And this H+ ions, they will be replaced. All the H+ ions are replaced with the calcium ions. Now the resin, it contains all the calcium ions. Now this H+ ions, whatever are there in this resin, that will enter into the water. Now I am allowing the water. No, these H+ ions will enter into the water. So if you see this diagram, see, initially only orange colored circles, that is H+ ions, are present. When I allow the water to pass into it, these purple circles are there. It represents that some of these H+ ions, means these orange circles, are replaced with the calcium and magnesium. If you understand this process easily, you can attempt this question, and even the same principle holds good for the anion exchange resin also. Okay, I hope till now you understood how the cations they are removed. Now whatever the cations that are present in the water, they got struck into this ion exchange resin, and the water it will be coming out of this chamber. So the water that is coming out of this chamber, what all it contains? The cations anyways it got struck into this. So the water that is coming out of this chamber, it contains anions and also H plus ions. Okay, let us, what are the anions that are responsible for hardness? Chlorides, sulfates, bicarbonates and carbonates. The main cations that are responsible for hardness are these. Now the water that is coming out of this chamber, it contains H plus ions and the anions. So what will happen? This H plus and Cl, they will combine to form HCl. And similarly sulfuric acid will be formed, carbonic acid will be formed. So the water that is coming out of this cation exchange chamber is acidic in nature. That is the important thing you have to remember. The water that is coming out of this cation exchange resin is acidic in nature, and it is free from the calcium and magnesium ions, because this calcium and magnesium ions, they got struck into this, or they are entrapped, they are formed linkages with this polymers, that is a cation exchange resin. Okay, now the next step is removal of the anions. Cations we removed, we got rid of the cations. Now we have to remove the anions. Now the water that is entering into this chamber, it contains H plus ions and the anions. Now when this water enter into the anion exchange resin, the same, what will happen? This anion exchange resin contains OH minus ions. These OH minus ions, they will be replaced with the chloride, sulfate, carbonate, whatever anions that are present, they will be replaced, and the leftover OH minus ions, they will enter into the water. So finally what is happening? From this resin, H plus ions are entering into the water, and from this resin, OH minus ions are entering into the water. So finally, the water which is coming out of this anion exchange resin is free from the calcium and magnesium ions, and it is also free from the anions, that is the chloride, sulfates, carbonates and bicarbonates, which are causing hardness. So the hardness causing salts are removed from the water, and the water is free from the hardness. So that water, it is called the soft water. Now, the important, after this hardness causing salts all are removed from the water, after certain time, these resins must be regenerated. Okay, regeneration means, just to see, here a resin is present, and let us talk about the cation exchange resin only. If we understand cation, obviously the same holds good for anion also. Now, my cation exchange resin contains all the three H plus ions. Just imagine H plus ions are present. Now when I pass water, all these H plus ions are replaced by the calcium and magnesium ions. What all H plus ions are present in this resin, they are replaced. Now if I add more water, can I remove the calcium and magnesium ions? I cannot remove, because the H plus ions are not available for the exchange. What is happening here? Exchange of ions is happening. If the H plus ions are not there, the calcium ions to whom they will exchange, they cannot exchange. So it means that the cation exchange resin or anion exchange resin, after certain uses, it will be exhausted, means regeneration must be there. Again, these calcium and magnesium ions which are present in this resin must be replaced with the H plus and OH minus ions. So for the regeneration of the cation exchange resin, we will be using dilute acids like HCl, dilute sulfuric acid. So this dilute HCl, it contains H plus ions. So now my resin is completely with the calcium and magnesium ions. Now I am undertaking the process of regeneration, means I am allowing the dilute HCl to pass through it. When I add dilute HCl into this solution, what will happen? What all calcium ions? This calcium ion, it will be replaced with the H plus. And what all magnesium ions that are present? Those will be replaced with the H plus. So what will happen? The calcium and magnesium ions which are present in this resin, they will enter into this solution. Means instead of this HCl, calcium will be replaced, means CaCl2 will be formed. These CaCl2 are nothing but they are just removed with the help of the washings with this outlet. So again, I am regenerating the resin. Once the resin, it is replaced with calcium and magnesium or chlorides, bicarbonates, or what all anions and cations to their respective resins, those are replaced again with the H plus and OH minus ions, so that the water, the conversion of the hard water into soft water can take place properly. This is a process of regeneration. So in simple, what is happening? First, I am taking the resin which contains H plus and OH minus ions. I am passing water. These H plus and OH minus ions, they are replaced with the calcium and calcium or magnesium or the chloride sulfates or the anions that are hardness causing anions. Once these are replaced, and next step is regeneration of the resin. For regeneration of the cation exchange resin, I am using dilute HCl. Again, I am passing this dilute HCl to enter into the resin. Now, what is happening? The calcium which is entrapped into this resin because of the passage of raw water or the hard water, they are replaced with the H plus. Similarly, for the anion exchange resin, I am using dilute sodium hydroxide solution, so that all the cations that are present in that resin will be replaced with the OH minus ions, so that further softening of process can be carried out. Okay, this is the process of regeneration of the exchange resin. So, if the next important thing you have to discuss in this is the formulas or the equations which are involved in this. If you see this, these are some of the simple equations which I have taken. See, RH, you know that cation exchange resins are represented as RH, and anion exchange resins, they are represented as R-OH. Now, with this cation exchange resin, I am allowing the hard water to pass through this cation exchange resin. Hard water means calcium and magnesium, which is nothing but it can be calcium chloride, calcium carbonate, magnesium carbonate, calcium bicarbonate, magnesium carbonate. It can be any salt. So here I am taking the example of calcium chloride. Now the anion exchange resin, it is passed with the water that is containing calcium chloride. Now what is happening? This H plus will replace with the calcium, and this calcium will go and sit in this RH, means that resin. So what is happening? Instead of this RH, calcium is obtained, and H it is replaced in the place of calcium, and HCl is formed. HCl is, as I told earlier, it is nothing but the acid, and that is the reason why the water that is coming out of this chamber, it is acidic in nature. Now, the water which is coming out of this chamber, that is nothing but the water, means the mobile phase that contains HCl. This HCl, when it is passed through this anion exchange resin, anion exchange resins, they are represented as R-OH. When they react with this R-OH, what is happening here again? The anions are replacing the OH minus ions, means the chloride which is present in this water or the raw water, it is replacing the OH minus, means R-Cl is formed, and H plus and OH minus ions, they are resulting in the formation of water. These are the simple equations, just the cation exchange resin and the anion exchange resins are used, and similarly the cations and anions are removed from the water. Now let us see some more equations like related to the cation exchange resin. RH, it is a cation exchange resin. If calcium bicarbonate is present in the water, what will happen? Now R2Ca is formed, and along with that carbonic acid is formed. This carbonic acid, it will be coming out of the cation exchange chamber. Similarly, if magnesium bicarbonate is present, the carbonic acid will be formed along with R2Mg. If magnesium chloride or calcium chloride is present, the acid that is formed is hydrochloric acid. This is very simple. Just replacing just you have to shift this one here and you have to shift this one here. Final result will be whatever products are formed, it is easy to remember also. Okay, next, this is a magnesium sulfate and calcium sulfate are the salts present in hard water. Then what will form? Sulfuric acid will be formed, that is H2SO4 are the acids that are formed. If nitrate is present, then nitric acid will be formed. Okay, once all these acids are formed, they are allowed to pass through the anion exchange resin, and there also the anions are removed, and the water which is collected from this anion exchange chamber, it is free from the hardness causing salts, means it is a pure soft water. Okay, these are some of the equations. Now regarding the regeneration, what are the equations that are involved? As I already told, in regeneration, for the cation exchange resin, we will be using dilute HCl, and for the anion exchange resin, we will be using dilute sodium hydroxide. If you see these equations, in cation exchange resin already it is R2Ca, means this RH is a cation. When it is replaced with the calcium, it will become R2Ca. Now this R2Ca, it is allowed to pass through the dilute HCl. Now what is happening here? The calcium, the just exchange is happening. Instead of this calcium, this H plus is going and replacing, and this calcium, it is combining with this Cl minus. So what is happening? Calcium chloride and magnesium sulfate, anyways they are formed and they are collected and they are removed. But in the resin, again RH is forming, means the regeneration of the resin we are making with the help of this dilute HCl and H2SO4. Similarly, the same holds good for the sodium hydroxide also. See, the anion exchange resin, when we first pass the hard water that contains hard chlorides, sulfates, how the resin it will be converted? It will be converted into R-Cl or R2SO4, like that. The resin structure, chemical structure, it will be there. When I pass sodium hydroxide, what will happen? This chlorine, it will go and replace this OH minus ions of the sodium hydroxide. So what is happening? R-OH is formed, along with that NaCl is formed. Okay, if I use if the resin contains the sulfate ions, then sodium sulfate and sodium nitrate, these are the washings that are formed, and finally our resin is regenerated, means R-OH is obtained. Now, finally, let us see what are the advantages and disadvantages of this ion exchange process. When I talk about the advantages, this ion exchange, the water that is softened by this ion exchange process, it is very pure soft water, means the hardness it can be brought down very low, as much as 2 ppm. Generally, 0 ppm water can also be obtained if we use efficient ion exchange resins. So, one of the main advantage of this ion exchange resin is the softness of the water, means it can be obtained very pure, means the hardness of the water can be brought down to 2 ppm, which is very low. Okay, another this is the hardness of water, it can be brought down to 2 ppm. Another advantage of this ion exchange method is highly acidic or highly alkaline water can also be treated with this ion exchange method. If the water is highly alkaline, means if it is more basic in nature, or if it is highly acidic in nature, whatever may be the nature of that water, that can be easily converted into soft water by this ion exchange method. So main two advantages of this ion exchange method is the hardness of water. It can be brought down to a very low value, as low as 2 ppm, and the second advantage is highly acidic or highly alkaline water can also be treated with this ion exchange process. And the second disadvantage means the next step, that is the disadvantages of this ion exchange process, is the resins are very costly. It is a very costlier process. The resins and the process, even for conversion of this process, or for performing this process, some skill or knowledge is required. Means the first disadvantage is the resins are very expensive and the cost of purification, it is very high. That is one disadvantage. The other disadvantage is if the water is turbid, means the turbidity of the water is more than 10 ppm, then the resins, they contain some pores through which the water percolates. Those pores will be blocked because of this turbidity. It is nothing but the precipitate nature. Those pores will be blocked and proper softening process cannot be taken place. Okay, so talking about the disadvantages, it is a very costlier process. The second disadvantage is turbidity of the water. It must be below 10 ppm. If it is above 10 ppm, the water, it cannot be, the softening of water, it cannot be performed properly. This is all about the ion exchange process. Ion exchange process, as I told earlier, it is an external treatment of boiler feed water, where the hard water, it is getting converted into soft water with the outside the boiler itself. That is the reason why it got the external treatment, why it is considered under external treatment method. And in this ion exchange process, the two important exchange resins that are used are cation exchange resin and the anion exchange resin. Talking about the cation exchange resin, it is represented as RH, and anion exchange resin, it is represented as R-OH. These cation exchange resins and anion exchange resins, they are nothing but the styrene divinyl benzene copolymers which contain a functional group. Means for cation exchange resins, the functional group is COOH, where H plus ions will be present, or HSO3, where H plus ions are important. And in anion exchange resin, the styrene divinyl benzene copolymers means nothing but the cross-linked high molecular weight copolymers will be present, which contain OH minus ions. Here, the H plus ions will be replaced with the cations, and the OH minus ions will be replaced with the anions that are present in the water. Thus, with the help of this exchanging process or replacing process, we are removing the cations and anions that are causing hardness to water, and finally a soft water which has a very low hardness, as low as 2 ppm can be obtained by this method. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.